Okay, it's slow. It's not moving. One moment. It's rebuffering for some reason. Okay. Okay, times minus 7 at the power of 8 times plus 2 at the power of minus 3 times 8 at the power of minus 1 over 3. 2, I will give you 3 or 4. X at the power of xy at the power of 2 at the power of 1 over 3 times yz at the power of 4 over 5 at the power of 5 over 8 over xz at the power of 1 over, it's rebuffering. I have to wait. I don't know why it's slow, but 1 over z at the power of 1 over 5 at the power of 15 over 2. 3, yes. You're cute, yes. X y z at the power of 1 over 2 plus 2x y square z minus x y square root of z minus 1 over 3 x y square z for 1 over 2 at the power of 1 over 3 times 2 over 3 at the power of 1 over 6 at the power of 2. One moment until it's rebuffering. Times 6 over 8 at the power of 3 over 4. So these are so far. I am moving this here. And 1.
Okay, so.
Do you want to dictate?
Yes, I think I can figure this one out.
Mm-hmm.
So minus 1 to the power of minus 3 would be 1 over minus 1 to the 3, which is 1 over, well, we can just figure that out in the next step.
Yes.
Yeah. Then times, do I expand minus 7 to the 8?
No, just calculate the sign.
Okay.
You don't do 7 times 7, so it's just.
Oh yeah, it's positive.
So it's 7 to the power of 8.
Mm-hmm.
Times.
1 1 over 8
Okay.
times, and then it's so it'd be cube root, right? Or no? I don't remember exactly, just this one part.
Okay, so it's because it's negative power, it's 1 over, it's buffering again. 1 over 8, root 3 of 8. One moment to I don't know what is happening. The internet is slow.
Okay, so it is root 3.
Over root 3 of 8 equal.
Okay, that's what I thought, just double checking. Okay, so then minus 1 to the 3 is minus 1.
Yes.
So that becomes just minus 1.
Yes, so it's minus times.
Do I just keep it as 7 to the 8, right?
Yes.
Times 7 to the 8.
7 to the 8.
Times 1 over 8. Times 1 over 2.
Times 1 over 2. So it's minus 7 to the 8 over 2 to the 4. And that will be the final answer.
Okay. Okay, yep. I understand. That makes sense.
So that's 1. Let's go to 2. Do you want me to repeat the rules?
I don't think you need to.
Okay, good.
Okay, so that becomes cube root of x and cube root of y squared and then times 1/8 root of y to the 5 and then square root of z.
Correct.
And then all of that over square root of x to the 15 and then square root of z to the 3.
Good.
So where do we have this? Thinking. Okay, I'm not sure what to do here.
Okay, so
we haven't had questions like this, and you're right, it is more difficult, but it's good because I'm learning new things.
Yes, that's the point, to give you something harder to learn. So when you have in school, the school problems are easier. So we can, let me give you the rules, okay? Root A x at the power of b. It's x at the power of b
over a.
over a. X at the power of a over x to the power of b. It's x to the power of a minus b.
Mm-hmm.
X to the power of a times x to the power of b. It's x to the power of a plus b. Okay? Now, we transform this expression in x to the power of 1 over 3 minus 15 over 2.
Okay, I see.
Times y to the power of 2 over 3 plus 5 over 8 times z to the power of 1 over 2 minus
3
over 2 equal. If we get a negative power, we are going to move it at the denominator.
Mm-hmm. Okay, so
It's equal.
2 over 6.
X to the power of, you dictate.
45 over 6. So it becomes x to the minus 43 over 6.
Correct. 2 minus 45, it's minus 43. Minus 43 over 6. Y to the power of
16 over, I mean, 24 minus. Y to the 1 over 24.
No. It's plus.
Oh, oops. 31 over 24, not 1.
Mm-hmm.
I was thinking minus still. And then z is just z to the minus 1.
So 2 minus 3, it's minus 1 over 2. You have the denominator 2, no?
1 minus 3.
1 minus 3, sorry, you're right.
It's minus 2 over 2, which is minus 1.
Minus 1, okay. Minus 1. Now, everything that is negative, we move at the denominator.
Mm-hmm. So that would become 24 root y to the 31 over 6 root x to the 43 times z.
Very good.
Okay.
Okay. Let me clean. I will keep the rules. Even they might not be necessary. One moment, it's slow. My internet is very slow today. Let me try to close some
Yeah, closing outside applications can help.
Yeah, to close. Yeah, other applications. Probably it's easier. Okay, problem number 3.
Okay, so we have to collect like terms.
Uh-huh.
So it would be x plus 2x minus x minus 1 over 3x.
No. What are the like terms?
Oh, what am I doing? No, what? No, forget I even said that.
Yes, so underline with the same type of line the like terms. Which are the like terms?
They are the
Here I erase one letter when here was a Z.
okay.
So you collect you write the like terms, you underline the like terms, and then collect the coefficients.
Okay, the Z is what made me a bit more confused. Okay, so the first and third are like terms, and then the second and fourth are like terms.
Mm-hmm.
So the first and the third one actually cancel out completely.
Mm-hmm.
And then becomes, so then it becomes 5 over 3 x y squared z.
No. Yes, 5 over 3.
Okay.
6 times 2 it's 3 times 2 it's 6 minus 1 it's 5 over 3
X y squared z.
Y squared z, and this is the final answer. Now let's go to 4.
Okay. So cube root of 1 over 2 times
Okay, do you know this rule? X to the power of A to the power of B, it's X to the power of A times B.
so it would be 1 over 3. So it's cube root of 2 to the 3.
One moment, I cannot write anything yet. Cube root of
2 to the 3.
Of 2 over 3, yes.
I mean 2, yeah, that's what I meant. 2 over 3. And then times 4th root of 3 over 4 to the 3.
Equal.
Okay. I know what I have to do, but I don't remember how to get there. It's
Let me know when you want me to say. want to think, good. If you want me to say, it's good too. Just let me know.
Oh. Wait. Okay, wait. You tell me. And
Okay.
just because.
So equal 1 over. No, not even that. Let's do even easier. Let's do even easier. So it's 2 at the power of minus 1 over 3 times 2 to the power of 1 over 3. Yes, that's this. Times 3 to the power of minus 1 over 3 times 3 to the power of 3 over 4. Do you understand what I'm doing?
Wait, how are you getting that?
Okay. So which one?
Just for example, the first one.
The first one. I will take it aside. So 1 over a, this is theory. I'm telling you the theory while we're 1 over a, it's a at the power of minus 1.
Yes.
Now, let's take blue. 1 over 2, it's 2 to the power of minus 1 to the power of 1 over 3.
Oh.
Okay?
Okay.
Times 2 to the power of 1 over 3, that's the numerator, times 3 to the power of minus 1 to the power of 1 over 3. Yes? Times 3 to the power of 3 over 4 times 4, it's 2 to the power of 2. 2 to the power of minus 2 to the power of 3 over 4.
Okay, wait.
So
this is brand new. We haven't, in class, we haven't done this before. So that's why I'm just.
yeah, no problem. That's why,
okay.
that's why I'm giving you hard stuff. So 1 over 4, it's 4 at the power of minus 1. 1 over 4,
yes,
4 at the power of minus 1, but 4 is 2 to the power of 2. 4 is 2 times 2.
Oh, so wait, you also have to do it with both the numerator and denominator?
Yes.
Except when the numerator or denominator is 1, because there's no. Okay, wait, so let me just.
So are you with me up to the number 3? Oh, yeah. It's buffering again. Are you with me up to here?
I understand. I think I understand them all now.
So 4 at the denominator is 4 at the power of minus 1.
Yes.
But 4 is 2 to the power of 2. So 1 over 4, it's 2 to the power of minus 2.
Okay, that makes sense. And then?
And everything is at the power of 3 over 4.
The
Because root 4 of a at the power of 3, it's a at the power of 3 over 4. So that's where the power comes here.
and then okay, last question is 3 to the minus 1 to the 1 over 3. How did you get that? And then after that, then I'll fully understand.
Okay, yeah, I understand. So you have 2 over 3, okay? Root 3 of 2 over 3
Yes.
is root 3 of 2. So it's 2 to the power of 1 over 3 to the power of 1 over 3. We move the power to numerator and denominator.
Mhm.
But this is minus. So it's 2 to the power of 1 over 3 times 3 at the power of minus 1 over 3.
Yeah. Oh. Okay. Okay.
Good?
It makes more sense now.
How can this number be so complicated? Be made so complicated when at school you get 2 at the power of 2 times 2 to the power of 3, no?
Yeah, it's we're doing like just this but very simplified.
You see how complicated, and I'm not doing harder that they are going to give you in school, depending of school, of course.
Mm-hmm.
So equal. Do you want to dictate from here, or you want me to say?
First thing I'm gonna have to do, yeah, like 2 to the minus 1 over 3.
Yes.
Times 2 to the 1 over 3. Which stays the same. And then times 3 to the minus 1 over 3. Times 3 to the 3 over 4. Times minus 3 over 2. Or times 2 to the minus 3 over 2.
Equal. Now we collect, if we have the same power, we collect the, if we have the same base, we collect the powers.
Okay, so it becomes 2 to the minus 1 over 3 minus 1 over 3. Oh, plus, sorry. Plus 1 over 3. And then minus 3 over 2.
Mm-hmm.
And then 3 to the minus 1 over 3 minus 3 over 4.
Plus 3 over 4.
Oh my God. I was just thinking of something from earlier.
Okay.
Okay, so then it's minus 2 over 6. So it becomes 2 to the minus 3 over 2.
Yes.
And then 3 to the 5 over 12.
If the power is negative, we are going to move it at the denominator.
Mm-hmm. So finally it becomes 3 to the 5 over 12. Unless you want me to write it.
No.
But I don't need to. Over 2 to the 3 over 2.
And that's a radical?
Wait, 12th root of 3 to the 5. Over square root of 2 to the 3.
Very good. Good?
Good. It's crazy how many steps
Yeah.
are in that question. It doesn't look like it would have so many.
Yeah. That's correct. So can I clear?
Yes.
I will give you x to the power of 1 over 2, y to the power of 3 over 4, z to the power of 5 over 6, everything to the power of 3 over 2 over x, y to the power of 1 over 2, z to the 4 over 3, everything to the power of minus 1 over 2. 1 over x at the power of 1 over 2 plus 1 over x to the power of 1 over 3 1 over x to the power of 1 over 2 minus 1 over x, y to the power of 1 over 2.
Okay. So for 1, it would become x to the 3 over 2.
Okay. X to the power of what?
3 over 4.
3 over 4, yes.
Y to the power of 9 over 8.
Yes.
And z to the power of, I just simplified it, 5 over 4.
Yes.
Over x to the power of minus 1 over 2. Y to the power of minus 1 over 4. Z to the power of minus 2 over 3.
Now we move everything up.
Mm-hmm.
Everything that is with minus at the denominator will be positive at the numerator.
Okay, so it becomes x to the 3 over 5.
3 over 4.
Oh, yeah, I just wrote it wrong by accident. 3 over 4 plus 1 over 2.
Yes.
Y to the 9 over 8 plus 1 over 4.
Mm-hmm.
And then z to the 5 over 4 plus 2 over 3.
Equal.
So x to the 5 over 4
Yes.
y to the 11 over 8 and then wait. Z to the 23 over 12.
(23 over 12). Very good. And now as a radical.
Then it becomes 4th root of x to the 5 times 8th root of y to the 11 times 12th root of z to the 23.
Good. Very good.
Mm-hmm. Okay. 2.
Now this is a little bit different. We need to bring common denominator. How do we do that?
Would the common denominator be x to the 1 over 6?
Let's think about it. I don't know. I just wrote the problem. I didn't think how to do it. I just made out the problem. We have to figure it out. So this is 1 over square root of x plus 1 over root 3 of x. So we have to have common denominator between these two. So if we make a root 6, something with root 6, it's something with 6 is correct, but we need to figure it out which one it is. So this is x at the power of 1 over 2 and x at the power of 1 over 3. What will be the common denominator? Oh, simple. You multiply the first one with the second one denominator, and let's try that.
That's what I was thinking of.
So you amplify this with root 3 of x, and you amplify this with square root of x. So let's see what we get. A root 3 of x over a root x root 3 of x plus square root of x over square root of x root 3 of x equal. Now, x at the power of 1 over 2 plus 1 over 3, what is that? X at the power of 1 over 2 times x at the power of 1 over 3. It's x at the power of 1 over 2 plus 1 over 3. It's equal with
5 over 6.
5 over 6. So it's root 6 of x to the power of 5.
Okay, so it becomes cube root of x.
Cube root of x.
Over 6th root of x to the 5.
Yes.
Plus square root of x over 6th root of x to the 5.
Equal
And is that all you can do?
Yes.
Okay. That's what I thought.
So this is a slightly different type of problem.
Mm-hmm. And now we have two variables.
Yes.
So
Let me erase, let me clean the page. Okay, can you dictate? Do you want to dictate?
okay, so it's 1 over square root of x minus 1 over square root of y. And then you amplify the side so it becomes, you amplify that by square root of y, and then the second one by square root of x. So it becomes square root of y over square root of xy. You can put them together. So, and then the other one is square root of x over square root of xy.
And then we write under one bracket, one fraction.
So that becomes square root of y minus square root of x over square root of xy. Okay.
Okay. Let me do something else. Okay. One. One over x squared minus 1 over x equal 7. 3, for example. Let's solve for x. Let's do this one, and then I will think. I have there is one type of problems, but I don't. It doesn't come to me. Let's find this one, and then I'll give you another one.
So first, would we work on the Okay, wait. Just seeing what to do here. So we would multiply all the terms by x first to get rid of the second, or we can do x squared, right?
You amplify the second fraction by x, and amplify this, because this is over 1, by x squared. You state first the restriction.
Wait, why do we amplify 3 by x squared instead of just x?
What is, you want to eliminate x squared, not x.
Oh, yeah. Oops.
First, you have to have the restriction. x cannot be 0. Okay?
Yeah. Okay.
So we have 1 over x squared minus x over x squared equal
3x squared.
over x squared.
Okay.
Then we eliminate, we multiply by x squared. So we eliminate the denominator. X being different from 0, we already state the restriction.
So then it becomes x squared.
No, it becomes 1. X squared, yes.
Yeah, x squared minus x to the 3.
No, 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 no. If you multiply x squared with 1 over x squared, you get 1. X squared times 1 over x squared, x squared,
Oh, yeah.
x squared, it's 1.
Yeah, so it's 1. 1 minus then that is x to the 3.
X to the 3 over
Yeah, x to the 3.
x times x squared times x over x squared, simplify.
Oh my God, what am I doing? What am I doing?
You understand?
Of course I know how to do this. My brain, it's just because of
I switched the type of problems. I told you.
yeah,
I'm
okay.
just doing a different type of problem now.
1 minus x equals 3x squared.
Okay.
All it
Now we
is.
need to solve for x to find the x.
Okay, so well, I can isolate x.
No, you move everything on one side and you have a parabola, equation of second.
Oh yeah, but
using quadratic formula.
That was a smart one. Because this is completely different. So my brain kept thinking of the other questions.
Yeah.
Okay, that was smart. I also got to watch out for things like that in case my school tries to do that.
They will, for sure.
So then it becomes 3x squared plus x minus 1.
Equals 0.
Yeah, equals 0.
Now we need to solve this one.
And then quadratic.
So quadratic formula, let me give you the quadratic formula. If you have ax squared plus bx plus c equals 0, x1 comma 2 is minus b plus minus square root of b squared minus 4ac over 2a. Did you learn this formula? Have you seen this formula before? I cannot hear you. You are blocked again. Hello? Are you there? Come back.